Hello, I'm Adil Abdul Nasser, roll number 30. In this video, we are presenting our project an optimization simulator for page replacement algorithms. This project helps us understand how operating systems manage memory efficiently using different page replacement techniques. And this is the main interface of our simulator. Uh, it consists of three main sections like input sections, and the performance results will be there and the memory visualization will be done. Here we enter the page sequence, which represents the order in which pages are requested. For this demonstration, for example, we have used here the page sequences as 7, 0, 1, 2, 0, 3, 0, and 4. And here we enter the number of frames, like which indicates how many pages can be stored in memory at a time. And here we can increment the number of frames. For example, we have taken 3 as the number of frames, and we run the simulation. After we run the simulation, where the all three algorithms FIFO, LRU, and optimal will be run. Here uh, we will be getting the performance metrics, and this is the page faults. Page faults occur when the required page is not present in memory. In this case, the system must load the page from disk, which takes more time. Hits Hits occur when the required page is already present in memory. This allows faster access without replacement. So, fewer the page faults and more hits indicates better performance. Fault rate represents how often page fault occur, and hit rate represents how often pages are found in memory. A higher hit rate and lower fault rate indicate a more efficient algorithm. For FIFO, we have 7 page faults and only one hit, which shows poor performance. For LRU, we have 6 page faults and 2 hits, showing improvement. For Optimal, we have 6 page faults and 2 hits, which is the best or near best possible result. This shows that LRU and Optimal perform better than FIFO for this input. This page fault comparison graph, each bar represents an algorithm. Like this represents FIFO, this represents LRU, and this represents Optimal. The height of the bar shows the number of page faults. We can see that FIFO has highest page faults, while LRU and Optimal have lower values. This graph provides a clear visual comparison of algorithm efficiency. And here, algorithm selection. Here is a drop-down list. From this, we can select FIFO, LRU, or Optimal. Currently, FIFO is selected, and this is the FIFO memory states. This uh, like here when in the step 0, this is the number of steps and this is each frames. Like in step 0, page 7 is loaded, and it's loaded into the memory, and since memory was empty, this results in a page fault. Step 1, page 0 is added to the next available frame, and in the step 2, uh, page 1 is added, filling all frames. Now page 2 arrives. Since memory is full, FIFO removes the oldest page, which is 7, and replace it with 2. Like in the step 4, page 0 is again requested. It is already present in memory, so this is a hit and no replacement is required. And in the step 5, page 3 arrives, the oldest page is removed and replaced with 3. And in the step 6, page 0 is requested again and is found in memory. So this is another hit. Like finally, page 4 is added by replacing the oldest page. This table clearly shows how the FIFO algorithm replaces pages over time. Now we can switch it to LRU. If we switch it to LRU, we observe a different behavior. LRU removes the least recently used page instead of the oldest one. This results in fewer page faults compared to FIFO. Final observation. From this simulation, we observe that FIFO is simple but less efficient. LRU improves performance by considering recent usage. Optimal gives the best but is not practical in real systems. So, in conclusion, this project helps us understand how memory management works in operating systems. It provides a clear visualization of how different algorithms behave. It also helps us compare their efficiency using performance metrics. Thank you.